What do you think, Rachel? Should I get going?
Yeah, I think so.
Okay. So, hi, everybody. This is me up here in the top of the grid. I'm Rebecca Pales-Friedman, and I want to thank you so much for joining us today for the Pratt Research Talk with Nancy Smith. So for 4 years, I was the research leader at the School of Design, but now I'm just passionate about design research, and I get to introduce the fabulous talks that we give once a month. The mission of the Research and Strategic Partnerships Office is to foster new and exciting research opportunities for faculty, staff, and centers at Pratt, and to help you make connections with each other. I know that it works great for me because I get to talk to all of the speakers before they speak, and it's wonderful. I've found out so many incredible things about the people that are involved in research at Pratt. So one way that the support is provided, it's by providing a platform for the research active faculty to talk about their work and to inspire each other, to inspire us to think about what might be possible with our own research at Pratt. So you can note that the presentations are all recorded and they're published on our YouTube channel. So if you see a talk and you think somebody else will really like it, please, I encourage you to share the recordings of the previous research talks or the ones that you're witnessing today. And also mark your calendars in the future for the talks that are coming up. On another note, we're always looking for presenters. So if you're interested in presenting or you know someone who would be great for our series, please reach out to them via research-partners@pratt.edu. And we can paste that email in the chat. You can also contact us through email or talk to me or anybody in the strategic office for research and what is it called, Rachel? The
Research and Strategic Partnerships Office.
Okay, I had most of the words just in the wrong order. And we're happy to talk to you and guide you through whatever steps that you need to take in your research. So today, I'm really excited to introduce Nancy Smith. I had a wonderful conversation with Nancy, and she's actually new to the Pratt faculty. This is her second year, and she's in the School of Information Sciences. And she teaches informational architecture. Now, Nancy, if I get any of this wrong, please chime in. But my understanding is that you teach informational architecture and anything that's UX, UI related that explores the navigation through information. In particular, your interest is in sustainable design. Nancy comes to Pratt from the University of Indiana, where she did her Ph.D. in human-computer interaction. And prior to that, she studied at the University of San Francisco. She has 2 master's degrees. She has an MFA in creative writing, and then she has an MA in media studies from the New School. So this isn't her first time in New York, although we have to welcome her back as a new neighbor. For many years, she's practiced as a graphic designer, and her work has led her through a career path from creating visual design of information to the theory of information architecture, especially how this information can be used to promote sustainability. So Nancy's research area is animal-computer interaction. This sounds so interesting to me. I can't wait to listen to her talk. And although she has a pet cat, her most recent research involves solitary bees. So please welcome Nancy Smith to our Brown Bag series.
Thank you. Thank you so much for having me. It's really nice to be here. That was a really nice introduction and pretty much captures exactly what I do. So today I'm just going to chat a bit about animal-computer interaction, which is kind of this weird little field that I'm in. And most people don't know too much about it or what it even is. So I'm going to talk sort of broadly about what it is and the kinds of things we do in this field. And then I'll talk a bit about my work with bees and talk a little bit about robotic bees and also living bees, mason bees. So let me just share my screen here. Okay, everybody see that? All right, so My title is a Nancy Drew reference. Hopefully you've all picked that up. So what is animal-computer interaction, or ACI? Whenever I say, oh, I work in ACI or I work with animals, people often say, oh, what's that? And I thought you were an interaction designer, or I thought you worked with people. And since my PhD is in HCI, which is a very human-centered space, and most technology is designed for humans and with humans in mind. So ACI is kind of a new field. It's really kind of a subfield of HCI. These are pictures from the Microsoft Research Center for Social Natural User Interface. So you can kind of see there's an orangutan playing with a computer. So this is part of ACI, is quite literally animals playing with technology, using technology, and potentially even using the same technologies that we use, but maybe in a slightly different way. But ACI goes beyond that as well, I think, to a lot of different areas. Cats playing with iPads, though, is a really nice way to think about it. So the area I'm most interested in is actually designing for and with animals. So that's really where my work is usually kind of situated, is thinking about animals. What does it mean to design for animals? How do we even do that? How do we conduct research with animals when we're used to interviewing humans or thinking about human design needs? How do we actually capture animal design needs, which is really a question that I don't think anyone has exactly the answer to, but we're thinking about it. Making tools to study animals. We'll look at a few examples of this. There's a lot of tools out there to actually study animals, where they go, how they move, especially for conservation. Designing technology to mimic animal behavior. So this is like biomimicry. We'll take a look at some robotic animals, which are some of my favorite things to think about, and to kind of think about what it means if we start designing robotic versions of animals, and especially when we talk about robotic bees in the second half. Facilitating animal plus tech interactions for humans, which is kind of what this is. This is really, even though it's an animal tech interaction, there's also oftentimes humans who are interacting. So maybe technology becomes kind of an interface for that. It could also be something like a panda cam. So even though we're maybe not exactly interacting, we're sort of getting to know animals that way. And then researching to understand animal-human interaction. So there's actually lots of technological ways we might gather data about how humans interact with animals, whether in particular spaces like agriculture and farming, or whether in your backyard or with your pets, and the ways in which you might spend time with your pets. So the question I think about a lot in pretty much all of my work is, well, how can we think about animals as part of our design practice and more broadly in HCI? So Clara Mancini, who's quoted here, she runs an animal computer interaction lab, and she's kind of known as really one of the main researchers in this area and somebody who's kind of coined this term. So it's hard to not think about Clara when we think about ACI, because she writes about it a lot and she does a lot of work with it. And she kind of highlights here that the study of interactions between animals and computing technology has never really entered mainstream computer science. The animal perspective has seldom informed the design of animal computing applications, whose development so far has been driven by academic disciplines other than computer science or by industrial sectors. The design of these technologies remains fundamentally human-centered, and the study of how they're adopted by or how they affect their users remains fundamentally outside the remit of user-computer interaction research. Which is to say, we often design things for animals, for example, like in an agricultural context, without really thinking about the animals. It's often still for the humans. So there's still a lot of work to be done to actually think through the animal perspective, and if they are our quote unquote users, what does it mean to actually design for them? So she runs this lab at the Open University, and she does a lot of work with dogs. So dogs are a big part of ACI. A lot of ACI work is around agricultural animals and domestic pets, which makes sense in that those are the animals we often interact with and have access to. And dogs, for example, are very used to being around us, so we can do lots of things. I see Amanda's dog now too. So I'm glad there are some dogs here. So one of the things that she's working on is she works a lot with service dogs. And so thinking about how you can make a home more friendly for dogs. So even though they might be doing things in the human world, like turning on lights, for example, they still have to adapt to our world and turn on the light that's at human height, rather than having like a paw-friendly button that's at their height. So she does a lot of work in that kind of area in terms of thinking about what they might need, what would be sort of easier for them from a design perspective. And so a lot of the questions she sort of asks here, this little quote here is kind of pulled from the site, but these are a lot of the questions I think about too, is how do we actually think about what animals want in the design of technology? So, and particularly in interaction design. So we know we're making all these technologies, some of them intentionally to interact with animals and some unintentionally. So there's lots of technologies out there that affect animals, even if we don't intend for them to do that, to affect them. So another concept that I think about a lot and write about a lot is this idea of decentering design. So this is a really good example of decentered design. It's not a computing design, but probably a lot of you are familiar with this. It's a wildlife crossing. And so these are pretty popular, especially in Canada. They're starting to become a little more popular here as well. And essentially what they do is they help animals cross over the highway so that they don't get hit by cars. And they are actually really effective in saving animals' lives, also saving people's lives so that they don't have accidents. And so even though this isn't a computing piece, I think a lot of ACI draws a lot from architecture, from industrial design, from product design, landscape design, because a lot of these areas are also starting to think a lot about the environment and about animals. So I see a lot of overlap between this type of design and some of the computing examples that we'll look at. And I think this is a good example of decentering design. And the idea of decentering design is most design is human-centered. And I think part of what I'm asking in my research is, what if humans were not at the center of design? What if we actually thought more ecologically or more holistically? And there's a lot of, I think, conversations happening around that term. And one of the critiques I often hear, which I think about myself, is people will often say, well, lots of humans are excluded from the design process too. So shouldn't we be designing for them too? And it's something I think about a lot, because that's absolutely right. And so I've started to think a little bit about decentering design as maybe decentering some humans, but maybe not all humans. But the idea really is not to put animals at the center. The idea is really that we actually think more about all these multiplicities of kind of beings in the same space. And so why I think this is a good example is this is a design that really helps animals and thinks about their perspective. Doesn't really affect humans though. So humans can still drive and do what they need to do, but they're also protected in a way. So it's kind of taking into account all of these various people. So tracking animals is a really big part of ACI. And arguably maybe some of the earliest forms of ACI, because we've been tracking animals with trackers for a long time, several decades. So this is from the Snow Leopard Trust, and they do a lot of tracking with big cats. And one of the reasons why I think of this in relation to this is in order for us to kind of understand where animals are going and how they move around, where they actually cross. So in order to build a wildlife bridge, you have to know exactly where they tend to cross. And they often cross in the same place, in part because they're usually headed for like a water source or food source. So they often kind of have patterns that they follow, which we can figure out if we're tracking them. So we can find the best place to actually put them. So a lot of ACI work ultimately ends up connecting with other fields of design in that sense, that we can gather data and then use it to do something. So rather than just the data in and of itself needs to kind of be put to work somehow. So another way of collecting data, this project is really interesting. It's called the Elephant Listening Project. And conservation of forest elephants is a real challenge. There's a lot of poaching, and it's really hard to keep track of forest elephants in particular because they're in a dense forest. It's hard to see them, it's hard to find them. So lots of kind of observation work just doesn't work as well. So what this project is doing is actually capturing sound data from elephants. So elephants have really unique sounds. They have voices like we do. So you can identify different animals by their voice and by the sounds that they make. And you can also learn a lot about how they're moving because they make sound when they move. So as they're kind of rustling through the trees and things like that, we can kind of pick up certain movements. You can also potentially record poachers and poaching activity because you can hear the poachers talking and there as well. So there's a lot of things you can actually pick up with sound, which is kind of a different way to think about tracking animals or collecting data about animals. And one of the big challenges with this project is if you have a ton of sound data, it's actually really hard for a human being to go through it all because you end up with hours and hours. You have multiple recording devices, hours and hours of record, days of recorded. You have so much stuff to go through. So what they're actually working on is a machine learning algorithm to actually process all these sounds. So they have to basically train the algorithm to understand these different elephant sounds. And then eventually, once the algorithm becomes strong enough, it can kind of process all of this and we'll have a much better sense of where the elephants are, what's happening with them, what's going on with their environment or with poaching, and potentially have a better way to intervene and to kind of see what's going on in these different areas. There's also really fun things like Google Sheep View. So this is like quite literally, if you want to look at some sheep, this is a really fun thing to do if you're feeling stressed out during the pandemic. Open up Google Sheep View. So this basically takes images from Google Street View that have sheep in them, and you can look at them from all over the world. And I really like this because I feel like ACI is one of those areas where there's really serious work going on and also lots of really playful, fun things going on as well. And I think that we need that range, especially with animals, and sort of thinking about the many ways in which we can interact with them. So Google Sheep View is just one of those things that I think is just a fun way to think about sheep. And in a more serious way, maybe it makes them more visible. So a lot of times, a lot of the work we think about in ACI is we often just don't think about animals. We don't really see them or think about them unless you're an animal person or unless you have pets or things like that. But a lot of times we just drive on by and don't think about them. And maybe this is a way to just make them more visible so people do kind of take them into account. There's also this, which is using a drone to herd sheep. So one of the things that happens in ACI is a lot of devices that are not intended, a drone was not intended to be a sheepdog, but someone is using it that way. And this has actually become relatively common practice to do herding with a drone, which to me is really strange. And I'm really curious to know, like, how do these animals feel? Like, are they scared or is it fine? Or, what are they actually experiencing from this? And one of the videos I saw, which I couldn't find a good video of it, but there was one with a lot of goats and sheep that were in the mountains, and it was a very precarious place. And it was actually really challenging for the shepherd and the dog to get there. And so a drone kind of allowed access to help the sheep come down. So it's sort of, depending on the context and the place, and, it's not something I'd ever thought of for drone use. And yet, here's one way to maybe use it and may be useful in certain contexts. And then another thing, this is kind of getting back to the realm of actually designing things for animals. So musical instruments, this is from a project called Animals Make Music, a look at non-human musical expression. Gray parrots are really, really smart, and they're really creative, and they need to be kind of intellectually and creatively stimulated. So a lot of designers, I think, are thinking about ways we can actually just engage with animals, whether our pets or whether captive animals or with animals sort of in the wild. There's a lot of discussion and debate, I think, around whether or not animals should even be in captivity. And that comes up a lot in my classes, and students often say, like, well, we shouldn't even have zoos. And I sympathize with that a lot, actually. But we do have zoos, and we do have lots of animals in captivity. And so for now, I do think this is maybe a way to make their lives better. But there's certainly a lot of ethical issues associated with this field in terms of thinking about animal well-being, animal welfare, particularly with agricultural animals, how they're treated, what we're doing with them, which go far beyond design. It's much more related to policy, politics, ethics. So there's certainly lots of those things that kind of come into this field, because I don't think we can just ignore them and say, oh, we want to design these things. We still have to engage with all of those big issues in which we're sort of situated. So in a lot of my work, I think about the climate crisis. I think a lot about the Anthropocene, this kind of epoch, this new epoch that we're living in. And this idea here that we need to develop the ability to think and act beyond human experience. And so if we need to develop that, I think one question for designers is, like, how do we do that? I think we've actually in HCI become pretty good at understanding other humans. We're often a lot of my classes, I teach methods for, interviewing or understanding people's needs or design needs. But I don't know if we yet know exactly how to do that with animals. You can't exactly interview an animal in the way that you might with a human. But I think this opens up a lot of possibility for really imaginative ways of understanding animals or experiencing what they experience. So this is a piece called Animal Superpowers by Chris Wobkin, which I really love. This is a piece actually designed for kids. And what is happening here with this little girl is she is actually experiencing life as an ant. So she gets to kind of see the world like an ant would see the world. So there's sensors in the bottom, and then it comes up so that grass is like really close to your face. So you can kind of experience the world as a really tiny creature. And he has several pieces in here. There's one that's also tall, like a periscope, and it's kind of like a giraffe. So a lot of it, I think these pieces, well, they're also really fun and creative, but they're also really important, I think, to help humans think more like animals, which is a big challenge when doing design work for them. We really have to learn new ways of maybe putting ourselves in their shoes, so to speak, or in their paws. So in this case, I think it's a way to maybe sort of think about how we might be able to do that, and how technology can maybe help us to learn those things and have those kinds of experiences, especially if you start thinking about VR and AR and those kinds of applications. And this is another piece. This is a speculative design piece and a critical design called respiratory support dog. And thinking about what I was just kind of talking about with exploitation, I think that a lot of folks in ACI are thinking a lot about the exploitation of animals and how we might be able to prevent that. If you think about the history of technology and animals, actually a very long history. So even though ACI is relatively new, once you expand that beyond computing technology, we have a whole history of agricultural technologies and various technologies that have been used to basically exploit animals. So this is a piece that's kind of suggesting, okay, what if this dog is helping this person breathe?
Okay, Bubba, you need to write one sentence here.
So just kind of, and I think it's a really provocative piece, and a really kind of, it's a piece that I think could be interpreted in a number of ways, and it's meant to be, I think. And this is speculative, so this dog is not being harmed in any way, but it kind of shows the ways in which we tend to utilize animals often as things for our benefit and things that can help us. And so a lot of my work is kind of looking at, okay, how can we do things for animals that may or may not really be about us? Ultimately, it's maybe about the environment or about improving things. So getting into robotic animals, one of my favorite things. So this one in particular, the biotic kangaroo, is one of my favorite designs. So Festo is a company that does a lot of robotics design, and in particular, they do a lot of animals. And part of why I find this interesting, for me, this is a really interesting object to think with. It's an interesting object to kind of speculate with. And so being a fiction writer myself who writes in sort of thinking about the future and science fiction, these kinds of designs also really inspire me in that way. And I think one thing that's nice about something like this is, on the one hand, you get sort of a very practical understanding of thinking about the way animals move, thinking about their functionality, thinking about what we can do in a mechanistic way. On the other hand, to me, it opens up a lot of possibilities or questions about the future in terms of, well, what kind of landscape are we going to live in the future if we have robotic animals roaming around, the savannah? Is that going to be the kind of future that we have? So for me, those are kind of more theoretical questions about what kind of future we might live in if animals start to go extinct, which they are, and we are kind of living through this big extinction. So here's a flying robot. And so Festo, many of these animals, well, I call them animals, but robots, don't often interact with other animals. They're often designed more to kind of explore different kinds of functionality. And sometimes the designs will actually then end up in other capacities. So Festo does a lot of like manufacturing robotics, for example. But you can kind of see here, I think in particular, one of the things that this brings up, which is a thing we think about a lot in biomimicry, is basically what kinds of materials can we use to replicate these movements? In this case, this has to be really lightweight in order to fly. And I'll get into robotic bees in just a second. And there's a lot of challenges with bees because they're very, very complicated. And there's a really interesting history of, part of my dissertation was actually about the history of automatons. And there's a really interesting history about animal robots, which I don't have time to get into too much today, but it dates all the way back to kind of thinking about both humans and animals as machines, and this idea that we can just mechanize everything. And now, of course, we really challenge that idea that we're not just machines and we can't just be reduced that way. But we're still thinking a lot in terms of functionality, in terms of what these animals can do, how they look, how they move, and that kind of thing. So this little Octobot, also one of my favorites. So getting into different materials, this is a soft robot. So that means it can really bend and move in ways that most robots don't. And so this robot is actually used in the ocean. So it can actually go down to where the octopuses live and interact with them and collect data with them. So it potentially allows us to go into places where we couldn't go. So it might be really alarming for sea creatures for us to go down there, or we might not even be able to fit into the places where this little Octobot could fit. So it potentially opens up opportunities for us to kind of get into new places and learn things about animals, as well as sort of learning how their bodies move or how their bodies work. And an octopus is also so complex that we would never be able to actually replicate it, but we might be able to start thinking about the way it moves. And I have this quote up here from Rosie Braidotti. So a lot of my work is grounded in posthumanism. And so this is, I think, a really great way to think about posthumanist thought, which is this idea that we're not entities, but ecologies. So rather than thinking of ourselves as sort of individual beings or animals and humans as separate, in fact, we think more ecologically. Even within our own bodies, we are full of microbes. You know, we've got all sorts of things going on in our bodies. And so do all of the other animals and plants. And we start thinking more in terms of an ecology. And I think that's one way of maybe kind of getting away from human-centered design to thinking more ecologically. This is Aibo, this is another little robot dog. So this one's much more like a playful dog. And this one really is meant to be like a companion for people. So you can sort of play with Aibo. Aibo will adapt its personality to you. So you can kind of change its personality a little bit when you interact with it. I included a quote here from Anna Singh, who's an anthropologist who I really love her work. And she talks a lot about worlding, which is something that we do. In fact, I'm teaching a class next week where we're going to talk about multi-species worlding. So it's on my mind. And she says making worlds is not limited to humans. You know, we know that beavers reshape streams as they make dams, canals, and lodges. In fact, all organisms make ecological living places, altering earth, air, and water. Without the ability to make workable living arrangements, species would die out. So in ACI, I think we tap into a lot of methods from other places. So worlding is something that a lot of writers know a lot about in terms of speculative fiction and kind of building out different worlds. And I think designers are starting to kind of tap into some of those things too, especially with speculative design. But even in terms of thinking about designing for animals, we have to figure out ways to imagine how they build a world, how they think of their world, you know, how do they kind of exist in space. And lastly, this big dog. I'm sure you've all seen the Boston Dynamics dogs. I feel like they get a lot of notoriety. I find them
We got her back.
Yay.
sorry, my worst nightmare. My internet just like went away.
Our worst nightmare because we were enthralled.
Oh, good. Oh, good. Okay. That was just like for a little suspense, you know,
Yes.
little tension, like what's going to happen next? And
Yeah, exactly. Commercial break.
We lost you right at the Boston Dynamics part.
Okay, excellent. I'm going to leave my video off just in case so that maybe it won't drain my my internet. Okay, perfect. So back to Boston Dynamics dog. Back to this terrifying creature. Actually, I guess this was good timing for a breakdown. Was like, this dog is so dystopian. Okay, and we're back. So yeah, this dog, I think kind of shows sort of the range of things that are happening with robotics. On the one hand, you've got Aibo, this like playful sort of fun dog that like kids can play with. And then you've got this dog, which is very much like a military grade machine. This is actually a DARPA project too. So it is absolutely a military kind of machine. So there is really this whole range of things. And this also brings up a lot of ethical questions about what this technology is used for. Whether or not it will be interacting with animals, it's hard to know for sure, but it will definitely be interacting with the environment. So it will be kind of, you know, traipsing through different environments and things like that. So this is one of the ones that I think gets a lot of notice because they do sort of really weird, creepy things. Let me just hit play here. There we go. So I wanted to kind of wrap up this part thinking about a question that I have a lot is dealing with sustainability. Sometimes the sustainable answer is don't use technology or don't add more technology to the situation. And so it's something I'll talk about a little bit when I talk about my Mason Bee project, because sometimes I'll be doing research and I think, oh, how can I build something for this space? And I think maybe I shouldn't be building technology for this space. Maybe we don't want to be, you know, using things that are already kind of inherently unsustainable. So this is a project, the Elephants and Bees project. So you can look up this project. It's a really interesting project. And what happens in a lot of places where there are elephants is if there are farmers there, the elephants will come in and eat all of their food. And so then the farmers get really upset and they want to kill the elephants or keep them out somehow. And so it ends up that elephants can be sort of a problem in this context. So the one thing that they have discovered is elephants are actually really afraid of bees. So if you put up a bee fence, they will stay out of the farm. So to me, this is a really interesting way of thinking about using design that's really not about digital technology, although Beehive is a different kind of technology. And you can sort of safely keep the elephants out. The farmers can continue to grow their food and nobody's really harmed. And the farmer also has bees to do pollinating work and potentially gather honey as well. So it kind of opens up all these possibilities. And so this is something I grapple with is, in the field that I'm in, teaching interaction design and thinking a lot about technology. Sometimes I find that maybe digital technology is not even what we need. And so how do we kind of maybe move away from assuming that's always the answer? So getting into bees for kind of the second part of the talk here, robo-bees, aka autonomous flying micro robots. This is what I wrote my dissertation about, actually. This particular bee here, there are actually several different kinds of robotic bees. This is the one that I looked at from Harvard. And you can see it's kind of like a little drone. So it's not exactly like a bee in the sense of a direct kind of biomimicry, but it looks more like a little helicopter. And there are a lot of functional challenges with this because bees can do some really amazing things in terms of flying and landing, and they're very fast and they can move really in really unusual ways. And so the robotic bee, it's been a real challenge, I think, for the designers to actually get this thing to land properly. So it's very much in the works. Like, this is not a design that's in the world, it's still in the lab. And it's hard to know if we'll ever have these out in the world. Will this become a common sort of pollinating device? It's kind of hard to know. So when I was doing research on this, I did a lot of interviews with engineers, designers, as well as beekeepers and farmers. So kind of trying to get the range of perspectives of people who would actually be impacted by this or who might be thinking about it. And I found that there was a really big difference in terms of perspectives. The engineers and the designers often talked about bees in terms of their functionality, in terms of what they can do. So this quote is a really good quote. She's one of the researchers on this project, and she says, bees are fast and agile insects. They can perform quick, aggressive maneuvers. They can fly through cluttered, dynamic environments. They can work both as individual as well as a collective. There was really no robotic or mechanical equivalent that had that biological complexity at that scale. So it's just a really rich area of engineering to explore. So I found that a lot of the engineers were really interested in this from a technical standpoint, which makes sense because there's really intriguing things going on technically in this design in terms of how do we actually mimic bees. On the other hand, I found that beekeepers were really worried about this design and they felt kind of like disturbed by it. So a lot of the beekeepers, I had a beekeeper tell me she thought this was dystopian. And she was like, basically, this means we don't care about the bees. We're just building technology to do the pollinating work. And she really thought of her bees. She had a couple of hives in her backyard, and she really thought of them as like her friends and like her pets, like her companions. So it was a really different perspective than thinking about them as like pollinating machines, as something that's just kind of doing that work of pollinating. So, in the dissertation work, a lot of what I was doing was trying to kind of gather up all these perspectives. And I found myself kind of back and forth as a researcher. It was like, on the one hand, I also find these a little dystopian. On the other hand, what if all the bees die and we actually do need these to do pollinating work? So the question of my dissertation really became, well, what happens when this becomes this, when the living bee becomes a robotic bee? And this was really the question that I think drove a lot of this research. It's something I still think about a lot. I haven't written about robotic bees lately, but it's still kind of on my mind of, well, what happens when we do take the natural environment and mechanize it? And this could extend even to artificial trees or, all these other things that are starting to emerge, that these things are not necessarily direct replacements, anything but, honestly. And particularly when you think about a bee as a social creature that has a community, honeybees in particular, they live in hives, they work together, they're incredibly smart. And then we have a robot, which works in a really different way. It's not really social in that way. It doesn't really have a community. It is a robot. So there is kind of this really big difference, and it becomes, I think, in certain ways, or can become a little bit reductive. But in the back of all of this is that, well, a lot of insects are dying. And so maybe this design is something that could save us, because if all of the insects die, we're also going to die. So it really kind of puts into light that we need to do something. But building a robotic bee, like the beekeeper said, doesn't really do anything to help the bees. And so we kind of end up solving this problem, which is a real problem in technology, is that we kind of try to solve a problem by like stepping aside and doing something else, but we're not really directly helping bees. And I think of all that engineering and design work that could maybe go into helping, the living bees. So one of the most interesting things about this research actually was the historical aspect. I really loved kind of diving into the history of bees because we have such a long history with bees. So the bee-human relationship goes back, millennia, and technology has always been a part of that relationship. So the Egyptians, many ancient cultures were keeping bees and had honey. And also one thing that always struck me was that they were also utilizing bees to pollinate in almost the same way we do now. So you probably are familiar with the whole idea of like trucking bees around the country to pollinate. So like in February, 3/4 of the bees get shipped off to California to pollinate the almonds. And it's really kind of a startling thing to think about, that that's how we utilize bees, and to think about how traumatic it probably is for the bees to have to move around like that. But in fact, Egyptians were doing the same thing similarly, maybe not on the scale, where they would put actually hives of bees on rafts and raft them up and down the Nile River. And then they would pollinate the things that were planted on the side of the river. So when I would read these things, part of me would be thinking like, wow, nothing's really changed. We're still kind of utilizing bees in a really similar way. And in fact, a lot of beehives are actually still very, very similar. So here are some older images. These are more from like the Middle Ages of different beekeeping. And it was also very interesting to think about bees as like a cultural entity as well. So one of the stories I love was like this idea of telling the bees, which is something they still do in certain cultures, which is when a beekeeper dies, they have to tell the bees and kind of give them a period of mourning. So they sort of put like black cloth over the hives and give them a couple days to mourn. And so this is something that still happens. So bees are also really, as much as I think of them as ecological or functional as pollinators, they're also really part of a lot of cultures and even like sort of, our spiritual and cultures as well. So there was a lot of really interesting things to dig up in this research. This is the leaf hive. So this is a more of a modern hive. It's very similar to the hive. If any of you are beekeepers or know any beekeepers, it's very similar to hives we use now, except it was originally more of like a leaf, like a book that you would sort of open and leaf through. And then the Langstroth hive, which is essentially the contemporary hive that most beekeepers here use, essentially is like that, but it's turned a little bit differently. And then the bees are kind of in slots in between. So thinking about smart hives and how does all this kind of translate into ACI, there's actually a lot of work out there in terms of how we might use sensors and things. So if you see anything called smart, quote unquote smart, that typically just means it uses a sensor of some kind. So this is a smart hive and it has sensors in it. And there's a variety of different sensors. This one's called BeeBot. So there's basically like temperature sensors, moisture sensors. One of the things that's really important for bees is the queen health. So there are sensors that are specifically kind of geared towards making sure that your queen is okay, because if your queen dies, the rest of the hive will die. So this is APIS. You can kind of see the kinds of information that you get. Basically, so you've got a little sensor up there in the right, but then your dashboard would kind of look like this. And you can kind of see, okay, these are all the different hives. You can see that it can diagnose disease, which is also really important in terms of bee health. So this is the kinds of information you might be able to get, which can be helpful in a couple of ways, in that you don't have to open up your hives to disturb your bees. So sort of thinking about the ways in which you might do this manually, beekeepers will open up the hive, check on their bees, which can be a little traumatic, especially smoking bees can be really traumatic for them. So smoke is kind of used to calm them down. But this way you could just kind of let them be and maybe monitor them. And you might be able to find a problem sooner. So you might be able to see, oh, something's wrong with my bees, I need to go out there, rather than several days later, you go check on them and it's too late. So sensing technologies potentially can help, you catch something earlier so that you can save your bees. So this little company called the Bee Corp, this is a little company in Bloomington, actually. So I was lucky to be able to interview the folks there when I was doing my dissertation. They have this thing called Verifly, which is essentially an infrared scanner that scans beehives to count the number of bees. And the reason they do that is bees, when they're sold, for pollination are sold by the number. So you have to know how many are in there in order to sell them, to then truck them off to do the almond pollinating. And so one of the things that you'll kind of notice about a lot of these designs is that they're geared towards commercial honeybees. You know, they really are kind of only designed for big commercial honeybees, which in certain ways makes sense. That's where the money is. And so that's where a lot of these technologies are. The last one here is this varroa gate. So the varroa mite is a mite that kills bees, like a parasite. And so what this does is when bees fly through it, it kind of traps the mites so they can't get into the hive. So there's lots of like very practical, I think, things that people are working on to try and protect the bees from the things we know that are harming them. But one thing I found in this research is there's not a lot of work on solitary bees. And so during the dissertation work, I was kind of frustrated that everything was about honeybees. And honeybees, as delightful as they are not necessarily the most important species. They just happen to be the domesticated ones that, we utilize for pollinating and we utilize for honey, both of which are industries that make a lot of money. So when I started thinking about my own work and projects that I wanted to do, I started thinking about solitary bees here in New York City. So there are a lot of solitary pollinators here. So solitary bees they don't live in hives like honeybees. They kind of live on their own in different ways. And they do a lot of really important work. But when we think about bees, most people tend to think of honeybees as kind of the quintessential bee. So I started working on this project last year. This was actually part of my seed grant from Pratt. So that was kind of my project, which you might have seen from the Research Open House last year. And so making kind of quote unquote smart mason bee houses. So thinking about mason bees, they live in these little tubes. So there are some bamboo tubes and then some cardboard tubes. So the first part of this project was really thinking about the form and the shape, what kinds of ways would these bees like to live. And there's actually lots of mason bee houses out there now. I feel like people are starting to put them in their gardens and it's starting to become more of a kind of a popular thing, which is really nice. And I was thinking, well, how can we use technology? What can digital technology maybe do for us? So this is one of the designs. This is one of the final designs of one of my bee houses. And essentially it has a little Arduino on it and it has temperature, moisture, and humidity sensors. The tubes are up here. They're also painted because one of the things that I've been thinking about, this is kind of an experiment to see if it works, is sometimes bees have trouble finding their home if all the tubes are the same. So imagine going to your home and every single home on the block looks identical. So this is sort of a way of giving them like an address, like you live in the red one on the right. So it kind of helps them to navigate potentially to the right place and sort of draws them in. So as I kind of mentioned before, a lot of the challenges here, I think, are around, do we really need this kind of technology? Like, is it important to have this, or could you just have a mason bee house with no sensors? You might be doing just as much good. And the way I sort of started thinking about it was potentially those sensors give us a lot of information about the environment. It's not just about the bees, but it's about where they live. So you could potentially be gathering climate information about your yard, which over time you could sort of see that things are changing, and you might kind of be able to think about the climate. I also thought of this project as something that's really accessible for kids or teenagers too, that kids would really be able to learn about the environment. And even with pretty minimal computing experience, you could put together something like this. It would not be too advanced. So I started to kind of think that like there are these benefits that you can sort of learn about, and you can kind of keep track of your bees that way. On the other hand, these are not really sustainable parts. They're not really recyclable. They are sort of cheap plastic and things like that. So it does challenge that idea of, well, how do we be sustainable when we're using, plastic and parts and things that are kind of never going to be recycled or never going to decompose. So it's definitely a challenge I think about a lot. This is one of the other hives. This is kind of a modular hive, and it's got some different tubes in it. This one also has a plant in it. So I was thinking a little bit, this one has a sensor that actually keeps track of the plant to see if it's thirsty and if it needs anything to drink. So this one's kind of thinking about plant health in addition to the bees. So trying to play with that idea of decentered design as well. It's maybe not just about the bees, but their environment. So in order for mason bee houses to be successful, they need to be around plants because the bees need to have a food source nearby. They also need to have water. So there's a little water source right here. And they need to be close to like clay or mud as well, because that's how they build their homes. That's why they're called mason bees, is they do little masonry work in the tubes. And so they kind of make their home in there. So you do have to kind of have certain things in your environment for this to work. And so I thought a lot about these as sort of urban designs that could go in your backyard, they could go on your balcony, assuming you have some plants there. I'm hoping to put some of these on the Pratt campus at some point. So these will be part of the Pratt garden eventually. So someday these will have a life outside of my home soon, hopefully. Okay, I'm almost done here. So I wanted to just mention Inclusive Ecologies at the end here, which is a research group that I'm part of at Pratt. And we're doing a lot of really interesting things around non-humans and decentering design. And so I feel really lucky to have connected with some other folks at Pratt, and I thought this might be of interest to some of the people here too. And so we've got some projects coming up, and it's mostly folks from architecture and landscape design. And I'm sort of kind of bringing the School of Information into some of these projects as well. So lastly, I just want to kind of wrap up with this quote, which I think guides a lot of my work and the way that I think about bees and everything that I'm working on. Alice Hovorka is a geographer who I really like, and she says, nature is no longer fixed at a distance, but emerges within the routine interweavings of people, organisms, elements, and machines, as these configure in the partial, plural, and sometimes overlapping time spaces of everyday living. So I feel like that's a kind of summary of how I think about this work, and sort of the challenges, both from kind of a theoretical perspective, but also from kind of a practical design perspective. And how can we sort of bridge those two things? Because it's one thing to kind of think about animals, think about animal perspectives. It's another thing to actually design stuff for them and for the world and for the environment. And so I see those as really kind of back and forth in my own work and how I kind of think about this. So that is animal-computer interaction and the bees in a nutshell. I'm glad my internet survived.
That was really wonderful. And you covered so much information.
Yep.
I feel like I definitely learned something. I hope other people feel the same way. And I also think that it's really interesting how your philosophy of technology doesn't always involve electronics, but can.
Mhm.
I think that's a really big takeaway.
Yeah, definitely. And I think in HCI, and I notice this a lot with my students, and even my own tendency is to want to turn to technology. You know, we want to design things, we want to intervene. That's, I think, kind of how we think about design. My cat has come to visit. And so I often kind of am telling my students, like, maybe that's not the answer. Maybe it's not just the automatic assumption that we need digital technology in this space, because you might find you don't. So I think maybe helps to kind of think through where, you know, the context in which that actually is going to be helpful and where it may be more harmful.
Yeah. Wonderful. Well, thank you very much.
Yeah, thank you for having me. And feel free to get in touch, you know, if anyone wants to chat about this anymore. If you know anyone at Pratt who's doing this kind of stuff, you know, feel free to put us in touch.
Definitely. Well, I told you I have a graduate student to send to you already. So,
Yep.
But thank you very much.
Great.
Okay, so the next one of our talks next month, just for you guys to put it on your calendar, is on February 17th at 12 p.m. And we'll have a talk with Sarah Nunberg. So please join us, mark it on your calendars if you don't have it already there. I'll talk to everybody soon.
Thank you.
Bye.
Bye.
Thanks, Nancy.
Thanks.